So as Patrick mentioned, our product is an application that sits on a server. In your case, you mentioned Windows. So yeah, it's an application. Sorry, a little bit of a brain fart there as I was thinking of the next things. Some of the sample code that he was talking about is in here, and he's going to send you this link, onlinehelp.opswat.com. This is an open help form. There's no needing to log in or anything like that, so you can get right to it. You can come in here, you can look at have associated with it as well as easy to follow install instructions and the like. So inside of the actual deployment itself, you have a couple of different dashboards to see what's going on as far as the efficacy of your current solution, how many files you're doing. Also in the online help that I was showing up here, we do have some performance metrics in there. Patrick did mention roughly about 2 million files per day. So a quick question to you, how many files per day and what file types do you think you guys are doing the most, or what are you doing in general?
So that's a good question. Since we were talking this, depending on how we deploy it and how, if we're going to do both sides, citizens and government agencies, that's a big question right there. So I really don't have any real statistics for you on that. And we also have a number of customers too. So, and this would also be customers would have to opt in, they would want to do this. So that really kind of depends on a lot. I'm pretty positive we would not be going over 1.5 to 2 million a day. That's not, okay. That would not happen. So
excellent. Okay, yeah. So let me go ahead and show you a couple of different samples of catching something. So essentially, what I would imagine is you would use that ICAP situation, or you would go ahead and utilize the APIs as part of it. And so what I'm going to do is eicar.com. If you're not familiar with that, that's just a test file that the majority of AV vendors are supposed to recognize. It's got a certain string that's inside of it that AV is supposed to recognize and say, hey, yeah, this is bad. But you can see here that not all AV vendors play that way, and that's partially because of how they do their discovery of files. So for instance, ByteHero is heuristic based. CrowdStrike didn't find anything, or Rocket Cyber, because they're an unsupported file type.
Okay, so the black X means they didn't find it. ByteHero did find it. ClamAV, did they find it or not?
Yeah. So what the X means, the red X means yes, they found it. They've termed it to be malicious. Here on the right-hand side, you can kind of see what they call it internally, because there is no real mandate out there to call it the same thing, right?
Okay.
ByteHero didn't find it, not because ByteHero is bad, but because of the way it does detection. So it's not a signature-based AV, and that's something to recognize with all the AVs that are in here. They're not all just signature-based. Some of them are heuristic-based. Some of them are machine learning, for instance, Sophos, etc. So in this case, this just means ByteHero doesn't recognize that string, didn't recognize that file as being malicious. So it's saying, hey, it's not really a threat. That's sort of a slight on ByteHero a little bit, because they really should just have a small pre-process in there that says, hey, find this file if it comes through, and say, yes, it's an EICAR file or whatever. But as far as the other ones like CrowdStrike and Rocket Cyber, it's an unsupported file type. So that's what the black X means. So in this case here, CrowdStrike is looking for a Word document or an exe or something like that, whereas eicar.com is just, it's just a test file. So this is what you get back, and inside of the API would basically spit out, a bunch of different infected with the results on it and the like. So I wanted to show you a couple of other potential ways of processing a file and what they do, specifically around that CDR bit. So if we come in here and I open up this JPEG right here, picture of San Francisco. Nothing inherently wrong with this picture. So what we're going to do is we're going to actually run this file through the process again.
Okay.
And what we'll see is that none of the AVs caught it. None of the AVs see this file as being hinky or weird or strange or anything like that. We can see here that the file type is JPEG. And if we come back to here, and if you're familiar with Linux at all, or you mentioned development, I'm actually grabbing what this file is from an OS level, right? And it says, hey, yeah, this is a JPEG image. So nothing there. And remember, right here, none of these AV engines found this as being malicious, but there's something hidden inside of this particular file. And if we unzip it, we see that there's a PDF file attached inside of that JPEG. Now, imagine that could have been an executable or virtual basic script. Essentially, I'm not going to run malicious code on my working laptop, etc. But same thing can be said for a PDF file or a Word document that has a VB script or macro in it or an executable as part of it. And I'll go ahead and open this and show you that, okay, it's just a squiggly line. There's nothing malicious about it.
Okay.
But as part of this process, what we did is we went ahead and we performed CDR on it. And we see down here we've got CDR, and it removes some metadata. That metadata happened to be that particular PDF file. But we can go ahead and download this, and we'll put it back in that same directory. And when we come in here, we can see that that file was processed by OpSWAT. It was sanitized. This right here happens to be the data ID for that file. So as part of the API, you can call up that file by that data ID. But what we can do is we can open this again. And what we see is we see the same picture. Go ahead and bring up this other one for comparison. The only difference is maybe the color is a little bit off because it's in the foreground versus the background.
Right.
But all the details are the same, right? This red car is still there. It's still there. We've got the pointy building, in the background. We've got some cars down here on the bridge. But interestingly enough, if we try to unzip like we did above, there's nothing there because it's been sanitized. And that's that metadata. One more I want to show you, one that actually came to me. So this was a file that I have diligently processed. I've put it through sandboxes. I've torn it apart. I've looked at all the files that have been dropped. Essentially, this was a quote unquote insurance scam that came through about 6 years ago, give or take. And even now, 6 years later, only about 18 of the engines recognize this as being malicious. And essentially, if we come in here, we can see that there were some macros and some images. We can actually click on the macros and look into this more. So from an investigatory perspective, I might have access to those sandboxes. I might want to see what's inside of here, but right away we can see that these things are variables that are random. And the reason why that happens is to try to avoid things like those AV engines, which is why we're seeing 18 of 29, because quite frankly, another one could have had the same sample, but with different variables inside of it. So from a signature perspective, it's slightly different, right? But obviously, just right off the bat, that's very hinky for there. But then you come down here and you start looking at things like, oh, they're trying to separate out a URL, HTTP savepix.su. Now, the interesting thing is I could go ahead and download this file and we could look at it again, but really there's nothing to it. It's just a Windows document that says, please enable macros or something along those lines. But it would be sanitized and would be allowed for you to go ahead and transfer that around. Now, the thing about our product, much like Patrick was talking about beforehand, is we only take a copy of the original file. So you will still maintain that original file. But with CDR, you now have what you can hopefully consider a clean file that can be shared around without having to worry about there being potentially malicious software in there. So anyway, this is the front end for MetaDefender Core. In this particular case, I'm currently using 29 engines. When you're using the cloud version, I believe it's 37. So the efficacy is slightly better in the cloud. However, with the on-prem version, you have that assurance that yes, the files are staying resident to my deployment. It's not going out anywhere. It's not being shared anywhere. Even though you don't have that concern with the paid for up as well, it's just even more comfort than that. As far as how things are processed, especially, are you currently using API for processing files to the cloud?
ACI being
API, so the programming
We're using
interface.
your RESTful interfaces.
Yeah. Okay. So, well, fortunately, I was just doing something earlier today where I was utilizing API. This is, as you can see, API metadefender.com. This is the information in Postman, which is essentially acting as that program for you. But all the information that you would normally have is in here as well. But the good thing is that when you are doing this to MetaDefender Cloud, it's pretty close to essentially the same thing. That the URL is going to change. One or two of the headers may change, but that's really all about it. So there isn't a huge lift to transfer from one to the other, but they're essentially the same thing. So when you process it, we'll go ahead and we'll select a file to process. In fact, we will work with my file tester. We'll work with the San Francisco JPEG file because I'm going to talk a little bit about CDR as well. So as you can see, we've got a picture of the Golden Gate Bridge, San Francisco. We're going to go ahead and process this file. And in the meantime, what I'm going to do is I am going to go ahead and open this file as well so you can see it a little bit more. Nothing, extraordinary about it, just a file, but it found exactly 0 problems with this particular file. However, there is something hidden inside of this particular file. And you can see here, I unzipped it, and inside of it was a hidden PDF file. So I'm going to, it's nothing, I'm not going to, run malware on my machine or anything, but it's to show you that for things like maybe data exfiltration. This could have easily have been a PDF file with an executable bit of code in there that's encrypted that you can't see, that isn't going to be caught by your standard AV just because of how it's formed and stuff. So you can't always rely on, excuse me, I clicked on the wrong tab. You can't always rely on the particular AV engines. Instead, you have to go ahead and utilize that CDR piece to it. And we can see here that some metadata was removed. And what I can do is I can actually download the result of this particular, not the scan result. I want to download the processed file, and we'll go ahead and save this. And I can show you that if we open this sanitized version here, as you see on my screen, that it is the same image. The only reason why it might look a little bit different is because one's in the foreground versus the background, so that sky color might be a little bit different. But otherwise, it's the same document. Because what we have done is we've gone through and we've either looked at the RFCs for the document type. So for instance, a lot of your image types are built out in what is the RFC. Or we've gone to the developer themselves. So for instance, we've actually worked with Microsoft and said, hey, if we have one of your documents that has active things in it, what can we take out of there that's active and you still have that document? So for instance, we'll remove macros, we'll remove VB scripts that are embedded, OLE objects, so that you as the end user, the document is still the document. It still has the text on there, it still has the pictures in there, etc. As far as from a human readable aspect, it's not changed. And that's that 0-day protection that Patrick was talking about. Now, as far as the other things, you may go to the website. I'm not sure if you do or not to look at information, but we have similar bits of information about these items, kind of like what the web does. And we saw this when it got processed, but essentially you have your engines here as well as your deep CDR details. You have things like your file type, which are all very similar to the cloud-based, except for that assurance that, hey, this stuff is remaining in my hands. So things like PHI isn't potentially escaping out there. As far as, like I mentioned, as far as the API goes, it's very similar to the other. There'll just be a couple of small changes for that small lift. I did want to show you one other thing. We do have email gateway security. So what I am going to do here is I'm going to write a message. I'm just going to go ahead and write it to myself because that's just how I have this test set up. And what I'm going to do is I'm going to attach, instead of the San Francisco one, are you guys familiar with what an EICAR file is?
Yep.
Okay, so I'm just going to attach this EICAR file, and then I'm going to send it to myself. So it is an attachment you can see here, and we will go ahead and hit send. And well, let me cancel this and go ahead and say test subject. And then this is a test of EICAR file. We'll hit send. It'll go ahead and send it. And then let's get our messages. Here's the test message. You'll notice there is no attachment to this message. So the subject is still there, the body is still there, but it has removed this file because, of course, an EICAR file is going to show up as being bad, right? And if we come to our processing history and we look, we see that we had an email come through. Here it is, email. It's been infected, and then when we click on it, it gets blocked because of the EICAR file. And so when we look into it, we see that, hey, this is the reason why that was blocked. So we've got that ability to do not only the AV scanning inside of email, but we could also do that CDR as well as part of that email too, where it would reattach the sanitized version or just completely remove, any type of item like that, completely configurable by you. So that is just sort of a quick demo. You're already pretty much familiar with how the product actually works. I just wanted to show you a couple of things around CDR and especially around email as well. What questions do you have, or what more can I show you?
So we see this example here through an email perspective. How are we using the product today?
So right now you're mostly using it for file uploads from what I understand. So it's basically just reaching out to MetaDefender Cloud, uploading the file there, getting the scan results back, and then making a decision on whether or not to allow it in. Correct me if I'm wrong, anyone on the other side of the team.
No, that's accurate.
Yeah. So yeah, the email module is something that's available to you, but it's definitely not the way the product's being used today. It's a great use case for that CDR feature, as Jason was saying,
Sure, yeah.
because you can make sure that everything's as safe as possible before it gets to end users, cutting out phishing attacks pretty much totally.
Mhm.
We also have ICAP integration. If you have, say, any web servers that you have users uploading things through, we can plug and play into F5 and A10 with the ICAP solution. It's another add-on for MetaDefender. Usually we can get those sort of deployments up and running, scanning files in about 5 to 10 minutes, whereas with simple MetaDefender integration, you do have to kind of do that RESTful API integration piece that can take a little bit of time. And then if you're doing any sort of storage in AWS or Box or any sort of cloud storage devices, we also have a solution for that as well. So there's a lot of different options for any ways that data is entering into your environment to make sure it's as safe as possible with MetaDefender before you allow it in.
So you can consume from, say, an S3 bucket if we provide files up that way?
Exactly. So basically we would scan the files before they went into the S3 bucket.
Mhm.
And then they would recursively be scanned from within that bucket. And I think Jason's going to show you the dashboard for MetaDefender Secure Storage is what we call it.
Yeah, so exactly what Patrick was saying. You can see here I've got a couple of AWS buckets created. One is a file upload bucket. So imagine your front end. This is where it's going to drop those files off. And then we've got several remediation actions that would take part. I don't have real-time processing turned on because it does take up cycles and it would be something I'd have to pay for over time. But this is more just a general idea of how things would be set up with storage units, as well as additional storage units, which I'll show you down here in a few minutes. But essentially, file upload would be right here. You've got remediation actions. We'll go ahead and take a look inside of what these remediation actions are. The first one is file tagging. So you can go ahead and tag those files. They will have the results, whether they're approved or blocked. A unique file identifier will be attached into that tag so that you can then go back to MDSS and get more information via API about that particular file, as well as the processing start time on it. We can also do CDR on it, where you get some options. So the file sanitization, and this bucket right here behind this window, I can't move this window, is my sanitized bucket. You can choose to keep the original file, in which case it will remain in file upload. I could delete the original file, in which case it would go ahead and delete it from file upload, and I'd only be left with a sanitized. Most people, I recommend you keep the original because you do want to have that original just in case for chain of custody type bits of information. And then finally, on your move and delete actions for remediation actions, you have if the file has been sanitized, where to move it to. If the file has been blocked, where do you then move that to? So essentially, the scanned malicious bucket is for files that were scanned malicious. And so what that does is it gives you a place for those things that the AV agents have said, hey, this file is potentially bad. Move it here, and then I'm not sure if you have a SOC or something like that, or if you have some malware experts, they can go in and dissect that particular file and look into it and see what's going on with it. Chances are really good that it's bad, but you have that to be able to go into and look at. And so those are sort of the remediation actions. And I don't have, so OneDrive and Box and then Dell Isilon. And we are going to be adding some additional cloud-based buckets in the near future, Dropbox, Azure, and then also as far as local network store, we will be adding on to that as well. So right now it's Dell, Isilon, and Nutanix, I believe, but it will just be general SMB shares as well in the near future. But this is basically a wrapper around MetaDefender Core. So if we look at our settings here, this is the MetaDefender Core, which if I click on this tab right here, you'll see up in the URL here. Essentially, MDSS is a wrapper, and it deals with those cloud-based storage buckets where you don't have to worry about creating an API to do the things for you. That's what MDSS does. So we're trying to make it easier for you in the long run to go ahead and assure that those files that are being uploaded aren't malicious.
So then if you could go back to the other screen that you were on with AWS buckets.
Yes.
So as things are moving in, the file upload gets put into AWS. Just trying to run through this all in my head so I make sure I'm at the right spot here. Remediation actions, file tagging, deep CDR. These are all manual actions, right? Taken by an analyst or?
No, these are all automatic.
So deep CDR will get kicked off.
Exactly.
Automated.
Yeah, so essentially real-time processing, you would turn that on, and then as files are uploaded, it would go ahead and go through that MetaDefender Core aspect of it. And then based off of your remediation actions, I'll just stay here. I won't click on it and open up other windows. It'll get tagged. So in AWS, a lot of things are done with tagging. At least how I've worked with it, it has. It'll also have deep CDR on it. What happens with the deep CDR is that it will get moved to sanitized storage. So you will keep the original file in file upload, and then the sanitized version will go into this bucket. And this is just, by the way, how I have it set up. I mean, you could have everything go right back to file upload and just use one bucket, but it's AWS. Why not use multiple buckets, et cetera. And then finally, the other things that it'll do is it'll move those sanitized files. So it's sort of like a double action, right? It's deep CDR plus moving the sanitized files because I want it to go to this other bucket. And then likewise, anything that happens to be malicious is going to get put into the scanned malicious bucket. So what that means is all files that have been scanned that aren't malicious will stay in file upload. And what we do as part of MDSS is we just check the hash first to see, hey, has this file changed? No, it hasn't. Okay, well, we already have a call on it that's good. So we're not going to go ahead and rescan it because there's no need to rescan something that's not malicious in a 24-hour period. So after 24 hours, it will scan that file again to make sure, because AVs could update that file all of a sudden didn't look malicious, but the AV's updated because they finally got the samples of those files to realize that it's malicious. And then they'll go ahead and change it. And then all of a sudden that file that's in file upload will get moved to the scanned malicious directory. But that is all automatic and nothing that you need to do. And then what you would do on the back end is, as part of your AWS program that you have going off, whether that's a Lambda function or something else or a different machine, making calls out, is you would then access MDSS via the API again to get this information either off of the tags or an API call, kind of like you do now, very similar to what you do now, to grab that file to move it to someplace else that you need to be.
Okay, that makes sense. Thanks.
Yep.
Yeah, so just so you're aware, we can offer you, the 2-week POC of any of these solutions, so MetaDefender Core or MDSS, so you guys can actually kind of run it through its paces and play around with it and make sure it's going to work for you ahead of doing any discussions on making a final purchase. So if that's of interest, just let us know and we can work with you to get that time set up.
So if we deploy on-prem, what does the infrastructure look like? Is it a Windows box, Linux, OVF deployment?
Sure. Yeah,
how do we manage it or maintain it?
Yeah, apologies for I actually thought I had that up on my screen inside of here, but yeah, recommended system configurations. So essentially, it can be Linux or it can be Windows. Just be aware that if it is Linux based, you will have fewer engines than if it's Windows based, and that's not something on our end. That's just because ABC, AV vendor doesn't have a Linux package, right?
Sure.
That doesn't mean that those packages that are on Linux only do Linux. They also do Windows files, etc. It's just the vendor, etc. So, but yeah, we have the configurations right here for that. I do recommend Windows just because if you start looking at the efficacy levels between the 8 and the 12 and the 16 above, there are big jumps between 8 and 12 and 12 and 16. So my base recommendation is at a minimum the 16. From there, you've got a couple of third-party items that you need to install. Some of them come by default, especially if you're utilizing like Windows Server 2019, which in that case, it's really just the redistributable that you need for these items right here. And yeah, I think that's about it. Patrick, anything else to add?
I don't think so. As Jason said, we would kind of recommend to go with Linux, but that's just because you're going to have more. I'm not Linux, sorry, Windows, because that's going to mean you have more AVs available to you. But if you're a Linux shop, feel free to go with Linux for any sort of PC. For the MDSS solution, currently that is on Linux. We are working on getting a Windows solution released, but yeah. So right now it will be a 10-engine package on Linux.
Okay, and then from a active kind of load balance perspective, how do you recommend managing the load balancer? Do you have recommendations for that?
Yeah, so for load balancing, we really don't. I believe inside of here, if I go into 10, this is where I was earlier with cloud deployment. And if you're doing like the AWS deployment, it has right here, you're just utilizing an AWS load balancer. Yeah, so we're rather agnostic on it. Most people will have like an F5 or something like that, and they can use that, yeah.
And we do. Do you have an F5 configuration that you provide as well? Is there anything special about it?
Not from the load balancing perspective. No, I don't believe so. And no, there usually isn't. Most people will do like a round robin to them. And then right here, it's not portrayed inside of here, but if you look right up here, specifically OpsWatt Central Management. So I'm going to click on another link back to this page here where you see where it's not managed. Basically, our central management system is a free download. You just download it, install it, and then you'll actually do your configuration, your lookups, etc., from the actual central management system. So that allows you to expand out from that 2 to 4 to 6 to 8, etc., and you just go to the central manager.
And then what is it like to maintain the product?
Yeah, so as far as maintaining the product, really the biggest one is the AV signatures. So long as the machines can go out, in this case, I believe it's to update.opswat.com. That's where it will get the signatures. As far as the actual version updates, so if we look down here, we've got Fort 19.1. That is a manual process. We kind of see that more as a security feature. We don't want our product to automatically go out and update, especially if you've got a dev environment or something like that. We don't want to do that. So the good thing is that this is basically an application that lives on top of the operating system. So you would just download the new update